3D printing is a process in which a person will develop a model or figure on an AutoCAD program via computer, and the software will then send the information to a printer, and the printer will start creating the model. The person who was behind the invention was Charles W. Hull, who has over 60 patents, and it was developed because of the idea where prototypes could be made using polymer and UV technology from computer technology. 3D printing was first used to harden tabletop coatings, and Charles was the one behind it. This technology itself has evolved over time. First, a virtual design and 3D file of a product is created. These 3D files are typically created with 3D modeling software such as computer-aided design known as CAD. Once the 3D file is finalized, the material that best fits the requirements and specifications of the product is selected. One of the distinguishing features of 3D printing is the wide array of materials that can be used, including various metals, plastics, ceramics, textiles, food, and biomaterials such as tissue. Additionally, various finishing options are available for the majority of these materials to produce a more desirable and accurate product. After the product has been printed, any options such as lacquer or paint are applied. Once completed, the product is deemed ready for use. There are several methods and processes for 3D printing, each with its own advantages and disadvantages. The main difference between all of the 3D print processes is the manner in which the layers are placed upon each other, and selecting which technology to employ depends heavily on the material that's going to be used. The selective laser melting (SLS) and fused deposition modeling (FDM) are the most common methods and involve melting or softening materials to produce layers. Other technologies such as stereolithography, known as SLA, involve a method for curing a photoreactive resin with a UV laser, or another similar power source one layer at a time. Alternatively, methods such as laminated object manufacturing, known as LLM, involve thin layers being cut into shapes and combined. Though 3D printing is rapidly expanding its reach across numerous industries and business sectors, the full extent of the technology's capabilities are just beginning to be realized. Rapid development of 3D printing systems is especially present in the following areas: architecture and construction, automotive, aerospace and aviation, medical and biotechnology, as well as apparel and jewelry. Architects are increasingly using 3D printing to create scale models of their designs. Previously, models had to be built by hand, thus costing both valuable time and money. However, 3D printing has reduced production time of scale models by 50 to 80% and result in models that are up to 60% lighter. Recent advancements with regards to accuracy, speed, and quality of materials in 3D printing have been applied to manufacturing strategies. As a result of 3D printing technology, researchers at the University of Southern California developed contour crafting, an additive manufacture processing that uses computer-controlled systems to streamline various construction processes. Car manufacturers have been using 3D printing technology for several decades, but only recently began transitioning from using the technology for concept model fit and design to creating individual parts used in test vehicles and engines. Also, the first car to be mounted using 3D printing technology named Irby was created in 2010. Due to developments in metal additive manufacturing, the use of 3D printing within the aviation and aerospace industries has increased and continues to grow. As a result of the partnership between NASA and Made in Space Inc., the first 3D printer to operate in zero gravity, the Zero-G printer, was created and delivered to the International Space Station by SpaceX in 2014. Thus, the implications of the zero-G printer allow for the printing of parts and tools on site. The uses of 3D printing are expanding rapidly as a result of developments such as 3D printed implants and prosthetics. Additionally, biotech companies are exploring tissue engineering applications whereby organs and body parts are created using inkjet 3D printing methods. Utilizing 3D printing in the future will bring about several issues in legality. One of the largest concerns is intellectual property rights. 3D printing will give the average consumer the ability to create anything as long as they have the proper schematics to do so. Also, liability will become an issue with 3D printing. Largest concerns for 3D printing are weapons and drugs. Now, everybody of all ages and medical conditions may be able to utilize 3D printing to go around the law and create illegal products. 3D printing or additive manufacturing looks to create employment growth. More items will be created within our nations, eliminating the need for manufacturers to outsource their products to go to other countries. With the use of latest technology, new technicians and mechanics, engineers and designers will be needed to utilize this field. Additive manufacture has already been put to work in our society. Many hospitals are using this technology prior to surgery to give the surgeon a better idea of the patient's organ. Many hope that 3D printing will help aid third world countries with more supplies at lower costs.